Hey everyone, I'm Jeff Mucklin and this is Science at Home, brought to you by the Nurture Nature Center. And this week I'm seeing red because we're going to be talking about Mars, the red planet. Mars is one of the 5 planets that have been known since prehistory. It can be seen with the unaided eye as a red dot. Its color has intrigued generations of imaginative humans who gave it names associated with death and violence because of its blood red color. The name we know it by today is no exception. Mars is the Roman god of war. It wasn't until the invention of the telescope that astronomers began to understand its true qualities. This map of Mars is one of the early attempts to understand its surface features. It was made by Italian astronomer Giovanni Schiaparelli with one of the best telescopes available in the 1870s. Unfortunately, his equipment was not up to the task, and he imagined seeing many details that aren't actually there. This is Mars as we know it today. Mars is the 4th planet from the Sun. It has about 1/2 the diameter of the Earth and only about 1/10 of the mass. Despite these differences, Mars is very Earth-like in a lot of ways. It has an atmosphere, albeit a very thin one, composed mostly of CO2 and it has almost no oxygen. It has weather, including events as familiar as winter and summer seasons, and it has dust devils and sandstorms. It has polar ice caps. Here's Mars's North Pole, and here's Mars's South Pole. There is water ice there, although most of what you're seeing is actually frozen carbon dioxide, essentially dry ice. It has mountains, including the tallest mountain in the solar system, Olympus Mons, that's it right there. That mountain is 2.5 times taller than Mount Everest. It also has valleys and canyon systems, including this feature over here. This is Valles Marineris, a canyon system 2,500 miles long. It has a 25-hour day and other similarities to the Earth. We have been sending robotic geologists to study the surface, which allows us to learn about aspects of Mars that we can't detect with telescopes. The first successful landing on Mars was the Viking 1 lander, which occurred on July 20th, 1976, followed closely by its twin, Viking 2, which landed on September 3rd of that year. It wasn't until 1997 before NASA was back on Mars, this time with Pathfinder. The Pathfinder lander carried a stereoscopic camera. It was a complete weather station with sensors for wind and temperature and air pressure. And it also deployed the Sojourner rover, which you can see here. It's a small solar-powered rover. It was the first roving vehicle to be used beyond the Earth-Moon system. The next Mars surface missions were the twin Mars exploration rovers named Spirit and Opportunity. Spirit and Opportunity landed on Mars in 2004 within 3 weeks of each other. Spirit continued to work and explore the surface of Mars for over 6 years. Opportunity only stopped communicating in 2018 after working for 15 years. Following on the success of the Mars exploration rovers, NASA landed a probe in Mars's North Pole in 2008 called Phoenix. Phoenix was not a rover, but like every lander before it, it had an array of sensors to help it complete its science mission. These included a robotic arm to collect samples, an imaging camera, 8 mass spectrometers, an optical microscope, an atomic microscope, a wet chemistry lab, a meteorology station. The Curiosity rover landed on Mars in 2012, and it is still working today. Curiosity is an enormous rover, able to study objects it encounters with unprecedented detail. The InSight lander is another stationary probe that is very similar to the Phoenix lander in design, but it has a new set of instruments. InSight will take the vital signs of Mars, its pulse with a seismograph placed on the surface by a robotic arm so that it gets accurate readings. Perseverance just landed on Mars on February 15th, 2021. Like the Curiosity rover, Perseverance is an enormous, well-equipped rover that landed using the sky crane method. Basically, in the span of just 7 minutes, the spacecraft had to slam through the atmosphere of Mars and slow down enough to safely deploy a parachute system that slowed the spacecraft even further until a series of rockets fired to keep the descent stage in the air while the rover is lowered on a cable to softly touch down on the surface. As if all of this doesn't sound hard enough, all of this was done completely autonomously without human intervention. Inside this virtual environment, I can get a sense for how large the Curiosity rover actually is. Up there, that is the mast camera. Down here, you can see some of the obstacle avoidance cameras. All of that is the robotic arm. The one facing us right now, that tool rotates, and the part that is facing towards us now is the drill, which will be used to collect samples. That thing with the fins on it, that's the power source right there. So inside that cylinder, there are pellets of plutonium-238, and the radioactive decay of plutonium-238 generates a lot of heat. And that heat is used by this thermoelectric generator to make about 100 watts of electricity at all times. This is what the Ingenuity helicopter looks like, and this gives you a sense of how big it is. It's about 2 feet tall. Ingenuity is another technology demonstrator designed to show that we can fly a helicopter on Mars. This is difficult because the atmosphere is so thin. In order to achieve flight, these rotors, these blades actually have to spin about 5 times faster than would be necessary near sea level on the Earth. It's all powered by a solar panel on top there, and that solar panel provides enough power to charge the lithium batteries inside of the Ingenuity helicopter, long enough to fly for about 90 seconds. So you can get one 90-second flight per day. I built this model of the Ingenuity helicopter to help me better understand how the one on Mars works. Now, my model is about half the size of the one on Mars, but it's pretty similar in a lot of ways. For one thing, you'll notice that if I turn the rotor on the top clockwise, the one beneath it moves counterclockwise. They're counter-rotating blades. This helps it stay stable in flight, and it prevents it from spinning out of control. You'll also notice this reflective coating on the outside of it. This is the same material that space blankets are made out of. It is an excellent insulator, and yet it's very lightweight. So when I turn on my model, you'll notice that it's flying itself. I'm not controlling it. It has sensors on it that allow it to sense how high it is from the ground, and it's controlling its height automatically, just like the real Ingenuity helicopter has to do, because remote control of a helicopter by humans from Earth to Mars is impossible because of how long it takes a signal to go from the Earth to Mars. The tools and robotic explorers that we've looked at in this video will help us answer important questions about the history of Mars, and some of those answers will help us better understand the history of our own planet. The answers to these questions are in the rock. Rocks are like books. They tell us about the past. The lines of deposition in this rock behind me are like the pages within this book. This is how geologists tell us about the past on worlds like the Moon or Mars or our own planet. Well, I hope you enjoyed learning about Mars with me today. A fun at-home activity that you can do is go see Mars for yourself. Like I mentioned at the start of the video, Mars is one of the few planets that is bright enough that you can see it without a telescope. Right now, as I record this video, you can find Mars on the western sky about an hour after sunset between the horns of Taurus the Bull. It's in the constellation of Taurus, right between the horns. So it's not that hard to find. If you have a star chart, it shouldn't be too difficult to find right now. But we will include a link that will show you the position of Mars and how to find it for the next couple months. So there it is. That little dot right there is Mars through my Dobsonian telescope. You can faintly see the reddish color, but that's about it. Luckily, we have much more powerful tools that we use to learn more about Mars and the other planets in the solar system. Thanks for joining me in this week's video, and I hope to see you next time. Bye. Bye.